The Elwha River on Washington's Olympic Peninsula was walled off from the sea for 100 years. Scientists assumed the wildness would drain out of it, generation by generation, until only a tame ghost was left behind the concrete. They were spectacularly wrong, and the way they were proven wrong is one of the strangest discoveries in modern biology. The Elwha is a short, powerful river on the Olympic Peninsula of Washington state, tumbling out of the mountains toward the sea. For thousands of years, it was one of the greatest salmon rivers on the west coast, so rich that it ran with fish said to reach 100 pounds, and it belonged, in every meaningful way, to the lower Elwha Klallam people, whose entire culture was built around those runs. Then, in 1913, two dams, Elwha Dam on the lower river and Glines Canyon Dam above it, were built across it, without permission and without any way for fish to pass. Behind them, the river was severed from the ocean. For the salmon, it was a catastrophe, but something stranger happened to one fish in particular. Behind the dams, a population of steelhead was cut off from the Pacific forever. Now, steelhead are one of the most remarkable animals in North America because a steelhead and a common rainbow trout are the exact same species. The difference is a choice written into their biology. Some go to sea, growing huge and silver, and come home only to spawn. Others stay in fresh water their whole lives as small trout. One species, two completely different destinies. When the dams sealed the river, the steelhead trapped above them could no longer reach the ocean. So, over roughly 30 generations, they stopped trying. They settled into being small, resident rainbow trout, living and dying in a few miles of Cold Mountain Creek, and never once seeing salt water. Biologists assumed the seagoing instinct was simply gone, bred out, discarded, the way evolution is supposed to shed whatever a species no longer uses. 100 years is a long time. The ocean, it seemed, had been forgotten. Meanwhile, the Klallam people refused to forget anything. Their right to fish the Elwha had been guaranteed in the Point No Point Treaty of 1855, a promise the dams had broken, and for decade after decade, they fought to tear those dams down. In 1992, Congress finally passed the Elwha River Ecosystem and Fisheries Restoration Act to do it. And after 20 more years of planning, the machines moved in. By 2014, the last piece of Glines Canyon Dam was gone, and the Elwha ran free for the first time in a century. What happened next stunned even the scientists who had spent their careers preparing for it. The descendants of those landlocked trout, fish whose great-great-grandparents had never touched salt water, began turning back into steelhead and swimming out to sea. Here's what the science actually found, because the real story is more precise than the myth. A team led by NOAA Northwest Fisheries Science Center geneticist Alexandria Frake analyzed more than 1,200 genetic samples from the river before and after removal. The trapped trout hadn't lost their diversity at all. A century of isolation had left their genetic toolkit essentially intact. That included the exact gene region, the GREB1L gene, that controls run timing, the switch that produces summer-run steelhead, a form that had been considered functionally extinct in the upper river for 100 years. And here is the twist that gives the whole story away. The landlocked trout, stranded highest in the mountains, carried the strongest version of that summer-run gene. The blueprint for the river's rarest, most lost fish had been sitting up there the entire time, hidden in creatures that looked nothing like it. When the wall fell, the river started cashing that blueprint in. Within about 2 years, summer steelhead, a fish presumed gone for a century, reappeared in the upper river. Researcher John McMillan and others documented their return in detail. Genetic testing of young fish heading out to sea showed more and more of them carried the ancestry of those above-dam trout, proving the landlocked fish were resuming their ocean-going lives. The total number of adult steelhead in the river climbed from fewer than 400 in 2013 to around 2,300 by 2021. NOAA scientists had a word for what they were witnessing. They called it a reawakening. And the steelhead weren't the only ones waiting in the dark. Even before the last rubble was cleared, bull trout, Salvelinus confluentus, a cold water fish that also needs long stretches of connected river, flashed past the old dam site and pushed upstream. They surged toward the coldest headwaters they could find, and their numbers more than doubled. Another creature, holding its breath for a century, exhaled the moment the river let it. Coho salmon, another of the Elwha's historic species, also began recolonizing the newly opened miles of habitat, their numbers climbing steadily as gravel beds that had been buried under reservoir sediment slowly reworked themselves back into spawning grounds. Then consider the Pacific lamprey, an eel-like jawless fish with a suction cup mouth full of teeth from a lineage so ancient it predates the dinosaurs by roughly 200 million years, having survived multiple mass extinctions. Most conservation stories ignore it because it isn't cute, but to the clallam, it's a treasured first food, and to the river, it's a quiet engine. Lamprey spend years as larvae buried in the riverbed, filtering the water and processing sediment before transforming and heading to sea. The dams had wiped them out above the concrete. After removal, lamprey didn't just trickle back. In a single tributary, Indian Creek, the count of larvae climbed from 132 one year to nearly 4,003 years later. That one creek alone produced over 40% of the river's new lamprey. Migrating juveniles rose from 71 to 600 to nearly 700 in successive years. And the crucial detail, biologists had transplanted only about 40 lamprey to help. Genetics proved almost none of the recovery came from them. The river was recolonizing itself from a fish nobody thought to celebrate. Then there's the creature still waiting. The western pearlshell mussel, Margaritifera falcata, can live more than 100 years, but it has a strange dependency. Its larvae can only develop by hitching onto the gills of a passing salmon or trout, riding along for a few weeks before dropping into the stream bed to grow. No migrating fish, no baby mussels. Above the dams, with the salmon gone for a century, the mussels simply stopped reproducing. They became living clocks, frozen mid-tick. Before the teardown, the tribe physically rescued mussels from the river, carrying them into hatchery tanks so the coming flood of sediment wouldn't bury them alive. And now, more than a decade later, biologists searching the reopened river are mostly finding old shells, not thriving beds. The mussel's return isn't a triumph yet, it's a vigil, a question the river hasn't finished answering. That's the real lesson of the Elwha. Evolution doesn't erase an instinct as easily as we thought. It locks it in a kind of genetic vault and waits, sometimes 100 years, for the door to open. The steelhead remembered the sea, the bull trout remembered the cold headwaters, the lamprey remembered how to rebuild itself from almost nothing, and the people who tore the dams down remembered a river none of them had ever seen whole. Tear down the wall, and you don't just clear a path. You find out what was still alive in the dark the whole time. And maybe that's the quietest miracle of all. Not the numbers, not the science, not even the fish themselves, but the fact that a river, given half a chance, remembers how to be a river. The Elwha didn't need us to save it. It just needed us to get out of the way. 100 years of concrete, and it took less than a decade for the wild to come knocking again. That's not restoration, that's a homecoming. And it's still righting itself, one returning fish at a time.